Okay, guys, this is going to be problem 7 on worksheet 10. Again, this one is rather long, so we are going to go through the steps and hopefully everybody will have a better idea of how to do these problems. The first thing is I have a little thing going on with my screen, right? I don't know, some formatting thing. But the reaction between solid sodium and iron 3 oxide, right, has something to do with an automobile's airbag. It gives you 100 grams of sodium and then 100 grams of iron 3 oxide. And then it's asked you to determine 4 things: the limiting reactant, the excess reactant, the mass of iron produced, and then the mass of excess reactant that remains after the reaction is complete. All right, so we are going to start first of all with balancing our equations. So it says that we have sodium and then we have iron 3 oxide, so that's Fe2O3. Okay. Now, if you look at this in any way, shape, or form, you should recognize this as a single replacement reaction. That means that sodium and iron are going to swap places. So I'm going to end up with NaO, and then iron will now be all by its lonesome. Okay, the first thing you need to do is make sure that all your formulas are correct. So sodium is not part of the Magnificent Seven, so we're good there. Iron 3 oxide, the formula is written correctly. Now, sodium oxide, it gives it to you up top, but I want to show you where they got it from. So sodium has a charge of +1, oxygen has a charge of -2. You need to cross your numbers, and that's how they get Na2O. And then, of course, you have iron, and iron is not part of the Magnificent Seven, so we are good on that front. Okay. So the next thing is you want to balance your equation based on what you got. So the best way to do this is, let's see, let's deal with the oxygens, right? That seems like a good place to start. So I have 3 oxygens on the left side. That means I need 3 oxygens on the right side. When you're balancing your equation, you're going to use coefficients, okay? Now that I put a 3 here for my oxygen, woo, we got a ton of sodium. So I have 6 sodiums on the right side. I need 6 on the left side, so I'm going to put a coefficient of 6. And then I'm going to check what else is out of whack. So my iron, I have 2 on the left side. I need 2 on the right side. I'm going to put a 2. And then I think we are balanced. So this coefficient is going to be 1. So 6 sodium, 2 iron, 2 iron. Yep, 3 oxygen, 3 oxygen. We are there. Okay. Now, please remember the steps to figure out these questions. We need to find the limiting reactant. We need to find the excess reactant. To find the limiting reactant, we are going to start with each reactant and we are going to go to the same product. I am going to pick iron as my product because the next question asks me for the mass of iron that is produced. Okay, so remember your basic roadmap that I tell you to build: gram of sodium to mole of sodium to mole of iron to gram of iron. That is step 1. Step 2 is gram of iron 3 oxide to mole of iron 3 oxide to mole of iron to gram of iron. Okay, so that's where you basically need to, that's basically the way that you need to go. All right, and then after that, remember, you find out which one produces the least amount. Okay, and then that reactant is the limiting reactant. Okay, so I'm going to erase the roadmap. Please make sure you keep it on your paper, but we are going to go through the steps in real time. Okay, so just give me a second so I can erase it. I'm doing that because I'm going to need a lot of space for this problem. Okay, so let's get back to what we're doing. All right, so I told you that step 1 is going to be us finding the limiting reactant. All right, so let's do it. We are starting off with 100 grams of each of the reactants. So I have 100 grams of sodium. I'm going to put that over 1. Gram in the numerator, gram in the denominator, mole on top. 1 mole is 23. It's actually 22.99, but it's okay. I'm going to round it up. I'm going to use my mole ratio. I have mole of sodium on the top, so I need mole of sodium on the bottom, which means I have mole of iron on top. When I take a look at my balanced equation, I am in a 2-to-6 relationship. And then I need mole of iron on the bottom because it's on the top in the previous equation. And then my molar mass of iron is going to be 55.8. I think it's 55.85. If you want to add the extra digit, please go ahead. Make sure your units cancel properly. Grams gone, moles gone, moles gone, mole gone, moles gone. I am left with 80.9 grams of iron. Okay, so that's step 1. I went from the first reactant to iron. Now I'm going to go from the second reactant, which is iron 3 oxide, and I'm going to take it to iron. Okay, so same thing above, just different numbers because we're dealing with different chemicals in the equation. So gram of iron 3 oxide on the top, put it on the bottom. Mole of iron 3 oxide here. 1 mole of iron 3 oxide has a mass of 159.6. Okay. Mole of iron 3 oxide, and I need mole of what I'm going to, which is iron on top. Look at your balanced equation. It is going to be in a 2-to-1 relationship. And then I have mole of iron in the numerator, so I need mole of iron down here in the denominator, and I'm going to go with my gram of iron on top. I end up with 55.8, and that's 1 mole, okay? Of course, as always, make sure everything cancels and you are where you need to be, and you will end up with 69.9 grams of iron, okay? This one produces the least amount of iron. That means that iron 3 oxide is your limiting reactant. So up here, I'm going to put Fe2O3, okay? And then if we know that Fe2O3 is a limiting reactant, that means that sodium is the excess reactant, okay? And when it asks you for the mass of iron produced, guess what? We already calculated that because that's right here in our first answer. So that's going to be 69.9 grams. And now it is asking you, what is the mass of the excess reactant that is going to be left over? So now remember, all the other questions you answer, you start with the limiting reactant amount. So I'm going to take my limiting reactant amount, which is 100 grams of iron 3 oxide, and I'm going to find out how much sodium I used, okay? So gram of iron 3 oxide on the top, gram on the bottom, mole on the top. We have a molar mass, it's the same as the one above, 159.6, right? And now we're going from mole of iron 3 oxide to mole of sodium, because that's what the question is asking us. And then we're going to take a look at our ratio, that is 6-to-1. And now I'm going to go mole of sodium on the bottom because it's on the top in the previous equation. And then I need the gram of sodium. I'm going to round up to 23, and that's in 1 mole. Okay, I do the calculations. I'm going to get 86.5 grams of sodium used. Okay, in the problem, it says that you started with 100 grams of sodium. So to find my excess reactant remaining, okay, and this is after remember, reaction is RXN is complete. And that is going to equal the 100 grams that they tell you we started with in the problem, minus the 86.5 grams that we used, that we calculated. And we're going to end up with an answer of 13.5 grams of sodium left over. Okay. So those are all of your answers that the problem is asking you for. So this is 13.5 grams. Okay. And that is it. So I hope that was helpful.